This tutorial covers the periodic statistics component, which performs statistical analysis on a set of hours based on a defined time interval. For example, this tool is useful for finding the weekly average, monthly diurnal highs and lows, or yearly sum of the values of each of the d-hours keys. To see its potential, let's start with a simple illustration. By using a quick heat map, we can see the effect of the component on a sample key. In this case, I've selected dry bulb temperature. But let's start fresh. Here we see a set of d-hours, and I'm going to pull down our primitive heat map, which we will be able to plug this statistic component into. So right-clicking on our set of d-hours, I'm going to input the name of the key that I would like into a simple panel, and pasting that in. We'll then need to bring down our periodic statistics component, which is found under the d-hour filter tab. And this requires just a couple of inputs. First we have our set of d-hours, and the second is the time period by which this statistical analysis will be performed. So we could use a simple panel to input words such as daily, weekly, monthly, etc. I'm going to use a pre-edited value list component, which can be found under the Inputs tab. And by right-clicking it, we can edit it so that it now reads all of our options. By putting in our daily period, we can then test it with a primitive d-hour and see what our mean output is. One thing to note is that our output d-hours are labeled surrogate hours. This allows elements to break gracefully downstream if there are an insufficient number of hours to input. We can see that our d-hours have been reduced to the 365 days of the year, and it still is retaining the 3 original keys. Plugging this into our heat map, we see a horizontal band of all of these daily hours, and if I had chosen a different element such as monthly diurnal, we would see that the diurnal number of hours causes it to be plotted vertically. And the number of hours are now 288, which is those 24 hours of the day multiplied by the 12 months of the year. So considering the rest of our outputs, we have the option to look at mean, which is the average of the values, the mode, which is the most commonly occurring value, the quartile values, or the sum of all of the values. The quartiles are defined by Q4 as the highest value, Q0 as the lowest, Q2 as the median or middle value, and then Q1 and Q3 as the 25th and 75th percentiles respectively. So let's see a sample spatialization created using this periodic statistics component. Here we see radial time value graphs, plotting average diurnal dry bulb temperature by drawing a line representing the mean values and a colorized band representing the broader range of second and third quartiles around the mean. More specifically, we've used the double gradient colorization for temperature and relative humidity to colorize these hours. And we've used the periodic statistics tool to pull the monthly diurnal values for the mean, Q3 and Q1 values of the colorized d-hours into a number of radial time value plots. We've set the value keys and ranges for a consistent range of dry bulb temperatures, and have created a consistent base plane and radial domain for the graphs so that they will plot together in the same space. From here, we've plotted the mean lines as a series of polylines using Grasshopper, and the colorized mesh is generated from the 2 perimeter lines of the Q1 and Q3 stats points and is similarly plotted. The labels and grid are also generated using Grasshopper components. And now through this spatialization of the periodic statistics component, we can more easily understand the temperature trends of these monthly diurnal cycles.